The combined gas law is great. We can manipulate pressure, volume, and temperature. But what about moles of a substance that we're using? Before we add moles to our equation, we need to figure out what the relationship is with other variables and find out if the identity of each gas matters. Because of Avogadro's hypothesis, equal volumes of gases at the same temperature and pressure have the same number of particles. This means the identity of the gas will not matter, just the number of moles. As you increase the number of atoms in a balloon by, say, blowing air into the balloon, the volume increases. The pressure is the same because the balloon can expand and the temperature is the same. So moles and volume have a direct relationship. Since volume and moles are directly related, just like volume and temperature are directly related, we can put the number of moles, or N, next to temperature. But now we're holding nothing constant, so let's hold one entire side constant by setting it to the STP values, and we'll call it R. And we can get rid of the division by multiplying on both sides. And you don't need the subscripts anymore either. And you get PivNert, the ideal gas law. Pressure times volume equals moles times a constant times temperature. So much beauty in such a small mathematical equation. Let's talk about what R is exactly. Remember, the R value is created from the equation set to STP values. So we plug in the values of pressure, the volume of a mole at STP, and the temperature at STP. And we get our results like this one. 8.31 kilopascal liters per Kelvin mole. But there are different R values for different pressure values, so make sure that you check your problem to see which units you need to use. At what pressure would 0.150 moles of nitrogen gas at 23 degrees Celsius occupy 8.9 liters? We're going to use PivNert here, and since we're trying to find pressure, we'll rearrange the equation to get pressure by itself. Now we just need to actually plug in our data. When it comes to choosing which R value to use, it's actually up to you in this case, since no specific unit of pressure was requested. I'm going to use 8.31 kilopascal liters per Kelvin mole because kilopascal is the SI unit. Now, don't forget, you need to turn Celsius into Kelvin whenever you're doing mathematical problems. Divide by the liters, and your final answer will be 41.5 kilopascals. Now, the ideal gas law makes some assumptions about ideal gases, so let's compare ideal gases to real gases. Ideal gases have no volume, but of course that isn't the reality. Real gases do have volume, and that will play a role in how it actually behaves. Ideal gases have no molecular attractions, but real gases are attracted to each other. In fact, when they cool down, they stop being gases and will form liquids and solids because of their attractions. Ideal gases follow the gas laws at all pressures and temperatures, and real gases will differ at low temperatures and high pressures. So basically, there's no such thing as an ideal gas. But real gases behave like ideal gases in many conditions. This is why we can still use PivNert, the ideal gas law. Thanks for watching this episode of Teacher's Pet. Don't forget to like and subscribe and follow me on Twitter @SciencePet.